Hello and welcome to this quick look at a Markovnikov's rule leveled response 6-mark question. So let's have a look at what the question wants first of all. There's 3 things to do, so therefore we need to think about a plan before we get started. So firstly, you need to take a bit of time to think of the structures of the 2 products that are going to be made, because that's the first thing that they ask you to do. Then they ask you to outline the mechanism. Now, thinking about the structures, what's going to happen in the mechanism is that the carbon-carbon double bond is going to break. Now that leaves one of those 2 carbon atoms I'm pointing at as potentially becoming a C+, in other words, part of a carbocation. So this is obviously the electrophilic addition mechanism that you'll know from alkene work you've done. And then you need to think about which of the 2 organic products is more likely to be formed. And when you do the mechanism, it says for the formation of one of the organic compounds. So you need to think about which one you're going to do the mechanism for. It looks like you've got a choice. So when you're thinking about the structures of the 2 products, you need to think about which carbon atom becomes C+. Is it this one? Or is it this one? So because we're reacting with hydrogen bromide, that will determine which of those 2 carbon atoms actually ends up having the bromine on it. Now, to determine which is going to be the most likely product to be formed, the 2 possible carbocations have different stability. And if you remember Markovnikov's rule, what it points to is, let's say this one where the highlighter was. You have 1, 2, 3 carbon atoms attached to this one here. So if this one became a C+, that's a more stable carbocation. If the carbon here on the left actually became C+, you have 1, 2. You only have 2 carbons attached, so that's a less stable carbocation. So obviously the most likely product is from the more stable carbocation out of the 2 options. So let's think that through again. What do we need to cover? Let's start with the mechanism. So what I've done is I've made the right-hand side carbon the positively charged C atom on the carbocation. So this is my carbocation here, this whole structure. And you've got a bromide ion, and the curly arrow can come off the minus charge, or it could come off the lone pair. It doesn't really matter which one of those 2 things you do. So it must come off either a lone pair or the minus charge. So like we said, that C+ now has 3 carbons attached. This is the most stable type of carbocation. It's called tertiary. So you can see in that little picture the trend in decrease in stability as you go from tertiary down to secondary and finally down to primary. Now, what's the alternative mechanism? That would be having the C+ on the left-hand side. So this time round, like we talked about a moment ago, you have 2 carbons attached. This would obviously be a less stable secondary carbocation compared to the more stable tertiary one we looked at a moment ago. So how do we need to construct our answer? Well, like we said, there's 3 things to talk about. And remember, we said that there's the formation of one of the organic products from compound A. So because they're leading us towards which of the 2 organic products is more likely to be formed, I'm going to go for the major product, as we call it, e.g. this is the one in this case derived from a tertiary carbocation. So I'm going to take that first version of the mechanism that we looked at. I'm going to put the structures of the 2 products. You can use structural formulae like this. So this carbocation is going to lead to the top one of the 2. And the reason this particular compound, 2-bromo-2-methylbutane, is more likely to form is because a more stable tertiary carbocation led to its formation in the mechanism. So you'll notice I've highlighted that wording in red because that's important language to use when you're doing exam questions about Markovnikov's rule. You must mention the idea of a more or less stable carbocation. That shows you understand what's going on. Okay, hopefully this has been a useful look at this question. Thanks for listening as always. Until next time, see you soon.